In this video, I'm going to talk about Pass MTU discovery. This is one of the features that we are using it in IPv6 automatically. Let me to explain it. You know that in IPv6, routers in the past cannot fragment the packet. Actually, only the sender of the packet can fragment the packet. Assume that here we have host A, router A and router B, and we are sending a traffic from the host A with the size of 2000 byte. Okay, this is possible. Why? Because as you can see, the MTU of the link between the host A and the router A is 2000 byte. Because of that, we can send a packet with the length of 2000 byte. This packet is receiving by the router A. Router A, after routing, understand that this packet should forward it to the router B over this link or this outgoing interface. Okay, and when it wants to send traffic to the router B, and it discovers that here on the interface connected to the router B, we have the MTU of 1500 byte. Because of that, the router A cannot forward this packet, and actually here we will experience that the router A is discarding this packet. Because of that, the host A should discover this process and this limitation, and after that the host A should send the traffic with lower or a smaller size. Actually, here we need a process that should occur in the host A, okay, to discover the minimum MTU of the path, and after that it can send the traffic. Here you can see the process. It is so easy. Let me first explain this process here. For example, host A now connected to the router A, and here the router A connected to the router B. We have a link with the MTU of 2000 byte in between the host A and router A, and we have a link between the router A and router B with the MTU of 1500 byte. And finally here we have a link after the router B with the MTU size of 1300 byte. Okay, what is happening when we want to discover the minimum MTU that we have in the past, or what is happening in the Pass MTU discovery process? Look at here. First, the discovery process works like this. First, a host like the host A, assume that the Pass MTU is the same as the MTU of the first hop link, and it uses that size actually with the 2000 byte. It is sending 2000 byte packet to the router A, and first the router A should drop this packet or should discard this packet. Why? Because you know that router A cannot forward or cannot fragment the packet over this interface, over the interface connected to the router B. But after, if the packet is too big for a certain router along the path to deliver the packet to the next link, the router discards the packet and sends back an IPv6 packet too big message. Okay, recall that this message type include the MTU size of the next hop link. For example, we are sending automatically from the router A to the host A IPv6 packet too big, and here we will send also the MTU of the next link. Here as you can see, next the MTU is 1500 byte. Actually, we are informing to host A that you shouldn't send the packet with the larger size of 1500 byte. Because of that, as you can see here, the host A in the next step, okay, now uses this MTU for sending further packet to the same destination. The host will never go below the IPv6 minimum size of 1280 byte. According to the RFC 2416, the minimum MTU that we can have on the IPv6 is 1280 byte or larger than this value. Because of that, here the host A reduces the host A should fragment the packet with to the 1500 byte. Okay, and after that it should send the packet. As you can see, the router A now forward the packet to router B. Again, router B understand that the outgoing interface's MTU is 1300 byte. Because of that, it should discard the packet and it should send back IPv6 packet too big message to the host A with the MTU of the outgoing interface 1300 byte. Again, in the host A, we are reducing the size of packet, or we are fragmenting the packet with the size of 1300 byte, and we can send this packet. This is the Pass MTU discovery. Don't forget, the host will never go below the IPv6 minimum size of 1280 byte. Okay. However, the process for receiving a packet to big message and reducing the size of the packet can happen more than once before the packet reaches its destination. The discovery process ends when the packet arrive at the final destination. The path from a given source to a given destination can change, and so can the path MTU. A smaller MTU size are discovered by getting packet to big message. And an IPv6 host will try to increase the MTU size from time to time in order to be able to detect a larger pass MTU. And pass MTU discovery also support multicast destination. If the destination is multicast, there are many paths that copies of the packet may travel, and each path can have a different path MTU. And you know that packet to big message will be generated just as with a unicast destination, and the packet size used by the sender is the smaller path MTU of the whole set of destination. Let me to show you one example. It can informative for us. Look at here. Here I have configured the similar scenario, R1, R2, R3, and R4. Assume that R1 is our host. I'm going to send traffic from the R1. Okay, and here we have a path between the router 1 to router 4. I'm going to send traffic, for example, to the loopback address that we have in the router 4. Look at here, I have configured this scenario, and now we can send easily traffic to the 2001 double column 4. Look at here, we have connectivity. Also, I have configured the MTU size of each interface. For example, in the R1, show interface serial 10 can show us the MTU of this interface is 2000 byte. This interface, let me to show you the labels of these interfaces. For example, the serial 10 has the MTU of 2000 byte in the router 1. In the router 2, show interface serial 10 has the MTU of 2000 byte, and also show interface serial 11 has the MTU of the, for example, 1500 byte, as you can see here. In the router 3, show interfaces serial 10 has the MTU of 1300 byte, as you can see. And then show interface serial 11 can show us that the MTU of this interface is 1500 byte. And finally, in the router 4, show interface serial 10 can show us the MTU of this interface is 1300 byte. Look at here, for example, in the router 1, show running config interface serial 10, it can show us that here I have configured the MTU with this command, MTU 2000, because the default MTU in most cases is 1500 byte. Or in the router 2, show run interface serial 10 can show us the MTU of this interface is 2000 byte, and the show run interface serial 11 can show us that I didn't configure MTU because this is the default value. And then in the router 3, again, show run interface serial 10, I have configured the MTU with 1300 byte, and because of that, now we can easily configure the MTU of one interface name, and also MTU can be configured. Now, let me to show you what is happening in the pass MTU discovery. For example, we can send traffic from the router 1 with larger size than the, for example, pass MTU. For example, we are sending the packet with 2000 byte of lengths. It is so easy. You can use ping command, and then with the size option, you can add this to the size of the packet. And here, if you want, we can capture the link between the router 1 and router 2. I'm going to show you the capture. It is informative. This is our capture related to this link. Okay. And after that, let me, for now, for starting the scenario, let me to shut down the interface of the between the router 3 and router 4. I'm going to show you step by step what is happening. Now the serial 10 of the router 3 is off. Let me to shut down it. Router 3 configure terminal interface serial 10 shutdown. Now, as you can see here, the neighborship ERGRP neighborship that I have configured before between the router 3 and router 4 now is failed. Because of that, in the router 1, now we don't have pass to the 2001 double column 4. I'm going to first discover the pass MTU between the router 1 and router 3. It is so easy. Look at here. This is our capture. In this capture, I want to show you what is happening. For example, from the host A means from the router 1. Now I'm going to send traffic to the destination of the 2001 DB8. Then 2, 3, :3. This is the IP address of this interface, the interface of router 3. Okay, actually, now we are sending traffic to this interface. Okay.